how the locust is unlocking the secret of how to create micro spies in the sky. They're fast, they're efficient, and the secret is in the way they flap their wings. Scientists have discovered how tiny locusts are able to fly such long distances by using high-speed video cameras to reveal how their wings change shape during flight. The Oxford University team created 3D models to show how the insects channel airflow much more efficiently than aircraft with fixed wings or rotors. It means engineers could one day build tiny flying micro-robots for surveillance or even military use, as our science correspondent Tom Clark now reports.
Just how insects manage to fly so precisely and so efficiently has fascinated scientists for centuries. But only the latest techniques, like this ultra-high-speed photography, have begun to reveal the true marvels of their evolution. Now, scientists at the University of Oxford, working with Australian supercomputing experts, have used these new images to describe for the first time how one insect, the locust, can fly for such long distances without needing to refuel. And they've built a computer model that works very much like a real insect.
That model's based on the detailed measurements we made of the shape of the insect's wings in flight. But the really critical thing is that we've also got experimental measurements of the flows and forces the insect produced. So we can compare what the real insect does with what the model does and check that the model actually works.
It turns out locusts constantly flex and twist their wings, so they create the most lift without wasting energy. In fact, they're 50% more efficient than if their wings were rigid. It explains why they're a voracious plague in tropical countries, flying hundreds of miles between meals. But the first working mathematical model of insect flight will pique the interest of scientists with a very different agenda. There's a reason for the buzz surrounding the science of flying insects, and it's a deadly serious one. Military planners would love to get their hands on tiny flying robots that could sneak into a hostile house or bunker and tell them who's in there before they decide whether or not to push the button. At the Defence Academy of the United Kingdom, part of Cranfield University, where the brainier among our military go to college, they're trying to build flapping micro-air vehicles for inside buildings, and insects are their inspiration.
An indoor flight requires a very special type of capability, namely flying at low speed, being very maneuverable at low speed, being able to hover, do it silently and in a power-efficient way. And only insects possess this proven capability.
Even though this lab leads the world on research into flying robo-bugs, their work hasn't quite got off the ground yet. Mechanical insects, usually evil, have a well-established surveillance role in the realm of science fiction and fantasy.
It's a spy fly.
Is it dangerous?
But the practicalities of re-engineering something that took over 300 million years to evolve isn't that easy in reality.
Because the wing motion is just fixed by the construction, so you have to disassemble it, change the size of the parts and then reassemble it.
Researchers here are now teasing apart the individual components that control insect flight, in this case a bee's wing ligament, to make artificial wings that behave the way the new computer models suggest. With ever smaller batteries and motors, they think they could have a free-flying prototype within 5 years. Though then they'll have to address the problem of the enemy's likely reaction.